Hello, this is Frank with Frank's Beautiful Rocks and Minerals. To see my collection of beautiful minerals and crystals, go to my website, Frank's Beautiful Rocks and Minerals. You can contact me at this video or at my email, chip613@verizon.net. I wish to identify commonly found rocks and minerals, the types of rocks and minerals that you would find around your house, at your local park, at your local dirt recycling center, and around town. A lot of these specimens are called dimensional stones. Dimensional stones mean that they are used in landscaping and in construction of buildings, such as marble. We'll look at some of these that you'll see and be able to identify around town, and some of the other ones that we'll find at your local park and dirt recycling center. To find a dirt recycling center, I suggest using a satellite image such as MapQuest or McNally. Zoom in on the satellite, focus in where you live, and start perusing around the area to look for what looks like piles. Drive out to those piles. There are probably excavated rocks and minerals. That's what I've done before successfully. So let's go over these. The first one is barite. This barite should be white, but it was found in the Arizona desert of the United States, so it's covered with red sandstone and it looks red. Barite frequently is of different colors, but most likely white, and it's very heavy. Barite. Halite. Halite is table salt when ground up. This is pink halite. You put halite down on your ground to prevent people from slipping when it ices over during a snowstorm. Agate. Agate's fracture is conchoidal. It breaks apart with no crystalline shape or form. It has frequently beautiful colors through it, and has sort of a look to it that looks like fudge candy. Lapidaries will cut it in half and polish it to look like this. Agate. Pyrite. Iron sulfate. Iron sulfate. Pyrite. Looks like it's called fool's gold also because it looks like gold or maybe brass. It's metallic. Fluorite. These crystals of fluorite have grown slowly in the environment and formed an octahedral shape. So it's called octahedral fluorite. Another type of fluorite looks like this. These are what's known as subhedral or fluorites. Anhedral, I mean. Anhedral. No crystalline shape or form to them. But these fluorites didn't have time to crystallize as fast as they solidified in the environment as these octahedral fluorites did. Fluorite. It's red sandstone. Sandstone appears like a rock covered with sand and it is not too heavy. This is red in color, so it's called red sandstone. Quartzite. Quartzite looks like quartz except that it's opaque. Quartzite tends to be found worn over in nature. Quartzite. And it comes in different colors, and red and white are the most common. Magnetite. Magnetite is iron. It's a magnet. On this piece, I have a paper clip attached to it. It's sticking to it because it's magnetic. Magnetite. This is a dimensional stone, and a stone used in cemeteries, but it's expensive. It's called green aventurine, a form of quartz. This is pumice. Pumice is lightweight, very lightweight. It can float on water. It was igneous in origin, coming out of volcanoes. Pumice. This is potassium feldspar with what's known as good cleavage. There's poor cleavage, good cleavage, perfect cleavage. It's kind of worn around, and almost perfect cleavage, good shape to it. It's found in granite, orange in color. Potassium, it contains potassium. Biotite mica schist has a sparkle effect to it, very sparkly. This is vesicular basalt. Notice the little pockets in it. This was once lava that flowed on the ground and had little chance to cool slowly, so the gases escaped. The gases escaped very fast, leaving the pockets. And then when it solidified up, it's a type of basalt, vesicular basalt. Do you recognize this? It's very lightweight, and its hardness is probably around, well, less than a 3, that's for sure. It's anthracite coal, used for heat burning in a furnace. This can be found at your local landscape florist. It's scoria. Scoria is also lava that had solidified with gases coming out of it, but in this case it contains more iron. Lava contains a lot of iron typically, and the bubbles in it, the little pockets, are much smaller than in vesicular basalt. Olivine. Olivine is green. And in the Bowen's reaction series, which I did a video on, it's called the most mafic of the rocks. It's very high, like peridot. Also, it's very high in iron. This is schist, and in the schist you see mica. Schists have a foliation in one direction, no cleavage, they're massive, and they show biotite mica in it, regular hornblende mica in it, white in it. Speaking of white, here's a vein going through basalt. You can find this at in a mall or a store's mulch, if you get permission to take it. It has either a calcite or a quartz vein in it. How can you tell the difference? I have some acid with me. You're supposed to use 10% hydrochloric acid. I use a higher concentration because I don't want to wait forever to make it fizz. Quartz will not fizz with acids. Calcites will. So what you do is you take a little bit of the acid, a little bit of hydrochloric acid, also called muriatic acid, and you drop the acid on the vein. If it fizzes, it's calcite. If it doesn't, it's quartz. Now that's fizzing. That tells me that's a calcite vein. Here's another mineral that reacts with hydrochloric acid. It's calcite. Calcite. This is white calcite. Calcite comes in a variety of colors, from clear to white. It's rhombohedral in shape. It has a rhomb shape to it in terms of a crystal. Halite. Mudstone. This is simply mud that dehydrated and stuck together. It's very flaky, very sandy. It comes off, it's very fine. It's not a sand, it's very fine grained. Mudstone. This is conglomerate. Conglomerate is a metamorphic rock that contains usually quartz in it. All the quartz that is contained in the conglomerate are of the same circular shape, and the pattern is consistent throughout it. I can't overemphasize that because it has a cousin named breccia. Breccia is a reference name for, instead of conglomerate, it has more square and jagged looking inclusions, and they're more infrequent, not evenly spaced apart from each other. Breccia. Metamorphic. Here's something. I found this specimen. This is petrified wood with calcite vein in it. And here's another specimen of petrified wood. Petrified wood comes from a tree that fell underwater and was underwater for about 10,000 years, and its biomaterials were taken over by mineralization, forming something called petrified wood. This is potassium feldspar granite. Granite is used as a dimensional stone in landscaping. It's quite frequent. It's also an igneous rock, meaning it was formed under the ground, but so close to the magma in a volcano that it was, in my opinion, it should be a metamorphic rock, but it's considered igneous. It formed this pattern. It consists of potassium feldspar and other rocks and other, minerals in it, such as quartz, and also hornblende. And it's solidified together with a very strong calcite glue. This is something you should recognize. It's very common. It's limestone. How can we tell it's limestone? What we do is we do our acid test again. Where'd my pipette go? Oh, it's in the bottle. If it fizzes, it's calcite. It's limestone or calcite. Limestone, And you can see it there. It is fizzing. This is limestone. Excuse me if I said something incorrectly before. This is a type of chert. This is black chert. It's heavy and black. Cleavage is a fracture, no cleavage. It's a fracture conchoidal. And it also looks like fudge candy. Just its look to it. It's one of the ways I can identify it. Hematite is rust, iron. Hematite, iron. It won't react with an acid, but it will rust and turn red. This is red aventurine, a dimensional stone, rather expensive, used in construction. It has a sort of a reflective red color on it, and sometimes it's found red and white. Diorite. Diorite is a volcanic rock consisting of biotite mica and quartz. Evenly spaced away from each other. Diorite. This is the very common marble used in landscaping and construction of buildings. Marble. I don't know, its hardness is probably around 4, and it's heavy enough. This is siltstone. Very fine particles. If you put a little bit of it on your tongue and then roll around on your teeth, you can, just a very small bit, you can crunch it. This specimen is shale. Shale comes in different colors, and this one happens to be red. It almost looks like slate with 1 degree of cleavage, as you can see there on the side. Slate. Slate is used in landscaping and construction. It's a dimensional stone. It's flaky, and as you can see, you can pull off little bits of it. 1 degree of cleavage. And here's hornblende. Hornblende is commonly found in pitch black. Hornblende. It's also found as veins in granite. This is olivine from the Sterling Hill Mine in New Jersey. Now we have a lot of discussion over, all right, let's go over this first. This is muscovite mica. It's got 1 degree of cleavage, which means that it's very flaky, and it comes off as in flakes. Muscovite mica. And the quartz. The quartz comes in a variety of colors. This is clear quartz growing on amethyst, violet in color. This is citrine, a yellow form of quartz. If you look at it through the light, well, it looks yellow. This is a dark specimen. This is rose quartz. It's pink in color. Smoky quartz. It looks black, but it's a very, very dark brown and translucent if you look at a small piece of it through the light. And here's clear quartz. The quartz here are euhedral, or having perfect cleavage, crystalline form called hexagonal crystals. Clear quartz. And here's clear quartz when it looks massive. It just looks it. This one is conchoidal, because unlike calcite, if you break quartz in the 2 pieces with a hammer, it just fractures. It doesn't have cleave. It won't turn into smaller crystals. It will just turn into, like these fluorites, no crystalline shape at all. You'll just break it in 2. Why is it like that? Because in nature, it needs to solidify by a seed, a small seed first, slowly, so that it forms that crystalline structure to it. Hitting it with a hammer will simply break it apart. The quartzes consist of, I'd suggest you look this up, Si silica, silica O4, 4 oxygens to each silica. But the silicon, I'm not sure how you'd name that. This type of silica bonds to other molecules in such a way that it creates bonds of SiO2, silicon dioxide, and that's quartz. So just to review, these are all the rocks we looked at. Going back to the beginning. And this is Frank with Frank's Beautiful Rocks and Minerals. And always remember to keep looking down.